In this class, now I am going to explain you mains standard applications from binomial theorem. This is third class from binomial theorem. In this class, now I am going to focus on coefficients of terms of binomial theorem. Simply, we are calling them as binomial coefficients. Before going to start this class, now I am requesting you to subscribe, like and share my channel so that my classes reaches to many people. Now let us go to the class. The first question is, see here, summation of I comma j are running from 0 to n. I is not equal to j. NCI into NCJ is equal to how much? This is the question, students. It looks like a very difficult question, but not difficult. It is very easy question. How to answer to that question? Now I explain you. Observe me. See here. Take this NCI, or simply it is written as CI, and here it is CJ. So here I is running from 0 to n. If you put I equal to 0, then it becomes C0. If you put I equal to 1, you get C1, like C2 till Cn, because I is taking up to n. Now here j is also running from 0 to n. Now put j0. So here j1, j2 till jn. So these are Cj values, these are Ci values, whose product we have to find here. Okay, students, see here, Cj, Ci. So C0 into C0, C0 square, C0 into C1, C0 C1, C0 into C2, and so on, C0 into Cn. So here C1 C0, C1 C here C0, C1 C1, C1 C2, and so on, C1 Cn. We have written the second row. Now go to the third row. Here C2, here you have to collect C0. Write C2 C0. Here C2, here C1, C2 C1, here C2, here C2, C2 into C2, C2 square, and so on, C2 Cn. Okay, go to the last row. So Cn C0, Cn C1, and so on, Cn into Cn. So here now we have written all those possibilities, and here before that summation symbol is given, which means that we have to add all of them. All of them. Okay. So these are I values, these are j values. Now this many possibilities are generated, whose sum we have to find. But here one condition is given, I is not equal to j. If I equal to j, all this possibility sum we have to find, but here I is not equal to j. So we don't want, so here this, in which I is equal to j, no? Here C0, C0, C1, C1, I equal to j, I equal to j. Those possibility sum we don't want. See how I am going to get this required possibility sum. First I would like to add all of them. After getting the sum, from which I can subtract this C0, C0, C1, C1, C2, C2, Cn, Cn. So this sum I subtract from the sum of all these possibilities. First, let us find sum of all these possibilities. See how I am going to find whose sum. First I want to add the first row. See Observe the first row, C0, 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 C1, C0, C2, C0, Cn. From all of them, what can I take common? C0 you can take common. If I take C0 common, here what is left? C0. Here what is left? C1, C2 and so on here, Cn. Now go to the second row, otherwise C here, C0. So sum of all these binomial coefficients, you know, whose sum is 2 power n. Keep it aside and go to the second row. So here C1 C0, C1 C1, C1 C2, C1 Cn. From all of them, I can take C1 common. If I take C1 common, inside what is left? C0, here C1, here C2 and so on Cn. Now, which is equal to C1, sum of all these coefficients, which is equal to 2 power n. Like, get the sum of all these possibilities. So here, what do you get? In the third one, C2 into 2 power n. And so on. For the last one, Cn into 2 power n you will get. Okay? So, this is the sum of first row. This is the sum of second row. So this is the sum of third row and so on. This is the sum of nth row. From all of them again 2 power n, 2 power n, 2 power n, 2 power n can be taken out. So inside what will be left? Here C0, here C1, here C2, here Cn. C1 plus C2 plus C3 and so on. So in the first one C0 taken common, no, C0, here C1, here C2 and so on, Cn into 2 power n. Okay students, here 2 power n is common from all of them. I took common. So inside C0, C1, C2, Cn. These are left, which are nothing but binomial coefficients only, whose sum will be 2 power n. Here into 2 power n. But is this our required sum? No. In which, so these possibilities are also included, which have to be subtracted. So subtract these possibilities from this. So that will be your required answer. 2 power n into 2 power n. Base is same now. Add the powers. 2 power 2n you will get, from which subtract this. So C0 square, C1 square and so on, Cn square. Okay students, now if you subtract this sum from this, what do you get? 2 power n minus, you know, C0 square plus C1 square and so on Cn square is equal to 2n Cn. You read this relation while you were learning the relation between the binomial coefficients. So this is one of the standard identity there. Remember, like a standard result. So this is your required sum for this given problem. Okay students, right, now let us go to one more application. See, summation r runs from 0 to 20, r square into 20 CR. This is the question. Okay students, how do you answer to this question? Here r is running from 0 to 20, r square into 20 CR. You know expansion. If you write r equal to 0, r equal to 1, r equal to 2 till 20. How do you answer to this question? So for this also we have one standard identity which you learned. So summation of r runs from 0 to n, r square into NCR. R square into NCR, which is equal to n into n plus 1 into 2 power n minus 2. So that is also one of the famous formula. Okay, even you have proved it, even it is there in the academic textbook also, a regular textbook. You have evaluated. Okay, that I am going to apply for this, but in the place of n, what is given here? 20 given. See here, 20. Just in the place of n, write 20. 20 into 20 plus 1, 21. So in the place of n, write 20. 20 minus 2, which becomes 18. So this is your required result. I hope you have understood. Right, students? Now, one more model of problem is there based on this identity. See that even this was given in previous mains. See that question. Summation r runs from 0 to 2023 r square into 2023 CR which is equal to 2023 into alpha into 2 power 2022. Then alpha equal to how much? Okay, students, this is the given question. Now get this alpha value. Yes, even this one also looks like previous identity only, na? In the place of n, how much is given? 2023. Now 2023 n into n plus 1. N into n plus 1. N into n plus 1. This is n plus 1. 2024 you will get. Previous formula I am going to apply. N into n plus 1 into 2 power n minus 2 na. So this I am going to apply for the left side. So 2023 into 2024 into 2 power n minus 2. N minus 2 means 2023 minus 1, which becomes 2021, which is equal to RHS. Yeah, 2023 into alpha into 2 power 2022. Now these two will be cancelled. Now see, actually what is our aim in this problem? We would have to find alpha value. So here we don't want this one. Send it to the left side. If you transfer to the left side, already here left side 2024 is there. So here 2 power 2021 when it comes to the left side. So this by this you will get, which becomes 1 by 2. Now divide this with this so that you will get 1012. Okay. Alright. Now go to one more application. I hope you have got it. Now see this question. Summation k runs from 0 to 10. 2 square plus 3k into ck, which is equal to alpha into 3 power 10 plus beta into 2 power 10, where alpha comma beta are any real numbers. Then alpha plus beta equal to how much? Okay, students. So this is equal to this, where alpha and beta are any real numbers. I want the sum of alpha plus beta. See, simplify this and equate this sum equal to this and compare alpha and beta. Alpha and beta. Okay, students. Now I am going to multiply these two with ck and I am going to expand it. So here if you take 2 square outside, 2 square here ck, k is running from 0 to 10. So put k0, k1, K2 till K10. So here 3 keep it outside. If you write 0 here, 0 into CK which becomes 0. Now put C1, 1 into C1 you will get 2 into C2 and so on, 10 into C10. Right. So 2 square value 4 students. So this is sum of first 10 terms. Sum of first 10 coefficients. So you know sum of all the binomial coefficients formula 2 power n. But here n value is 10 now. So 2 power 10 you will get plus. So here 3 into. What about this? So here 1 into C1, 2 into C2, 10 into Cn. You read this formula. N into 2 power n minus 1 which is equal to 1 C1, 2 C2 and so on till n into Cn. So I am going to apply this relation in place of this. So here n value is 10. So here 10 into, so 2 power 9 you will get. 2 power 9. Okay? I hope we have got it. So this formula you read in the concept. N into 2 power n minus 1. See. Now from these two, what do you take common? 2 power 9 you can take common. So here 8 will be left because here when you take 2 power 8 outside, here 1, 2, here 8. 2 4 is 8. So 2 power 9 went outside. 3 into 10, 30. Yeah? Yes, 30. 30 students. Right. Now, okay, compare this one with RHS. What do you get? So this is LHS after simplification. Now go to the RHS. Alpha into 3 power 10. Now beta into 2 power 10. Now there is no multiple of 3 here. Alpha into 3 power 10 is given RHS, but there is no 3 power. Hence I want to confirm alpha 0. If I keep alpha 0 here, it is going to be how much students? So see here 2 power 9 and here 2 power 10. So which becomes 2b. 2b which is equal to 38. Now your b will become 19. Beta, sorry, not b. Beta will be 19. Okay students. So here alpha is 0, beta is 19. Then alpha plus beta is 19. So this is the required answer for this question. So this is given. I have sent this one inside. So I have expanded. I got this one. 2 square value 4. 4 into this one. Sum of first 10 binomial coefficients. Whose sum is 2 power n. So here 2 power 10. Now here 3 I took common. So whose sum is n into 2 power n minus 1. Yes or no students? N into 2 power n minus 1. So I applied that. I got here n 10. Okay students, n value is 10 now there? Yes. So 3 tens are 30, 2 power 9. So from both I took 2 power 9 common, here 2, here 4. 2 4 is 8 left here, 3 tens are 30, 38. So 2b equal to 38, beta is 19. There is no 3 power 10 LHS. Hence I kept alpha 0. Because in the problem they said alpha and beta are any real numbers. Now alpha plus beta equal to 19 is the required answer for this question. Now let us go to one more application. see this question, students. Easy only. See here. Summation k runs from 0 to 20. 20ck whole square. Now here k is running from 0 to 20. So if I write k0 here, 20c0 whole square. If I write k1, 20c1 whole square. If I write k2, 20c2 whole square, and so on. So 20c20 whole square. Yes, you know, c0 square plus c1 square plus c2 square. Just now I said to you one formula. So what is that? 2n cn. c0 square plus c1 square plus c2 square and so on. cn square, which is equal to 2n cn. You read in the concept. So this looks like this formula. In the place of n, 20 is there. Hence this result would be, in the place of n, write 20 m, 22 is 40. 40c, 20 is the required answer. Okay? Right. Next. Right. Now I am going into other application. See this. Summation r runs from 1 to 20, r square plus 1 into r factorial is equal to how much? This is also one of the good problem. Now see, observe me how I am going to evaluate it. In the place of r square plus 1, I would like to write r plus 1 whole square, okay, minus 2r into r factorial. This is only bracket, not a greatest integer function, normal bracket. So r square plus 1, you can write r plus 1 whole square minus 2r. If you want to expand it, r square plus 1 plus 2r, 2r cancel, you will get this one only. Okay. Now before this, here r equal to 1 to 20 is there. Now in the next step, I am going to apply this summation symbol for these two terms. So here r runs from 1 to 20. So this r plus 1 whole square, I can write r plus 1 into r plus 1. I am multiplying with r, so that I will get, so here r factorial. Okay students, here minus, what is there? Minus 2r into r factorial. So that I am going to write, see, inside only I want to keep it, r into r factorial and minus summation. So here r is running from 1 to 20, r into r factorial. I hope you have understood this. So here, when you send this one inside, minus 2 into r factorial you will get. But this one I split as minus r factorial minus r factorial. So this minus r factorial I kept inside of this bracket, and this one I kept outside. Why? You will come to know in the next step. So in the next step, this I am going to write as summation r runs from 1 to 20, r plus 1 into r factorial can be written as r plus 1 factorial inside of the bracket minus r into r factorial minus summation r runs from 1 to 20, r into r factorial. Oh, you have understood. Now let us go to simplify this sum. If I simplify in the final, what I will get? So if you want, you can expand here. Put r equal to 1. If I write here 1, 1 plus 1, 2. 2 into here 1 plus 1, 2. 2 factorial minus, so here 1 into 1 factorial. If I write 2, 2 into 2 plus 1, 3 no? 3 into 3 factorial minus here 2 into 2 factorial. Now just r equal to 1, r equal to 2 I kept, I got 4 terms. If I simplify, big and small is leaving. Like that, if I simplify up to 20, so big one will be 20 plus 1, 21 into 21 factorial minus 1 into 1 factorial will be left on simplifying this. I have not written 1 to 20 students, just I kept r equal to 1, r equal to 2. I got 4 terms. This 4 I simplified, this and this gets cancelled. So big and small will be left. Like that, if I write all those possibilities and if I simplify, so maximum value and minimum value will be left. Maximum value when it comes, whenever r is writing as 20, 20 plus 1, 21, 20 plus 1, 21 factorial minus students small value 1 into 1 factorial. So this is the final simplification of this. Now here this is known to you like a standard formula. So you read, so summation of, so this r runs from 1 to n into or r into r factorial is equal to n plus 1 factorial minus 1. In many places you learned. Same that one also you have to simplify like this only. But remember like a standard result. N plus 1 factorial minus 1 you will get. But before this bracket minus sign is there. When you open the brackets the signs will change. Here minus bracket of n value 20. 20 plus 1 21 factorial minus 1. In place of this, I applied this formula. N value here 20. 20 plus 1, 21 factorial minus 1. Now simplify that. If you simplify, so you are going to get 21 into 21 factorial minus 1 into 1 factorial minus 1. So if you send this is inside, minus 21 factorial minus into minus plus 1. So now both of them cancel. Now these two are left, from which take 21 factorial out. 21 minus 1 into 21 factorial. 21 minus 1, 20. 20 into 21 factorial is the required answer for this question. Okay students, right. Next, students, see this question. This question is, see, if 30C1 whole square plus 2 into 30C2 whole square plus 3 into 30C3 whole square and so on, 30 into 30C30 whole square. So which is equal to alpha into 60 factorial by 30 factorial whole square. Then alpha equal to how much? Then alpha equal to how much, students? So this total sum is equal to this much is given. Then alpha equal to how much? Okay, shall we answer? Right. See here. I would like to take this total sum as S. We have 30C1 whole square, 30C2 whole square. Here, before that 1 is there. Here 2, here 3, here till 30. Now shall I write this one as 0 into 30C1 whole 30C0 whole square? 30C0 whole square. Wantedly have added this. Yes, you can add because 0 into something 0. This is total. Yes. Now same series I would like to write in the reverse order. So first I would like to write here the last term here 30 into 30C30 whole square. So that last one I have written under this, and last 2 second 29 into 30C29 whole square. Next last 2 third 28 into 30C28 whole square, and so on. Under the last one 0 into 30C0 whole square you will get. I hope you have understood how I have written this. Now I am going to add corresponding terms in both series. So here S plus S 2S, and when you add these two 30 plus 0 30, I am adding, students. So here 30C0 30C30 both will be equal to 1. So here 30 plus 0 30 only will come. 30 into, in place of this 30C0 I would like to write, because both are equal. You know, NC are equal to NC N minus R. You read this one in the binomial expansion. So coefficient of NC are equal to NC N minus R. You know, as per that, so both will be equal. You can write NC0 whole square and add these two. Here 29, here whose coefficient 1. So both are equal. Take this are common. So 29 plus 1 30. 30 into 30C1 whole square. Like that, if you add all of them, 30 into last one 30C30 whole square. Now here 2S. From all of them here 30, 30, 30 is there. Take 30 common. Inside what do you get? 30C0 whole square. So here 30C1 whole square, and so on 30C30 whole square. Now which is equal to 2 ones are 215s, because we would have to find sum of this series, which means that you have to find S. We have taken this series sum as S now. Our aim is to be calculated S. So I cancelled this 2 with 30. I got 15. Now what you have got inside? C0 square plus C1 square plus Cn square, which is nothing but 2nCn. No? I gave you this formula in my previous applications. So apply that. 2n, n value is here 30. 2 into n, 2nCn formula. This I am going to apply. N value 30. 230 is a 60. 60C, n value 30. Okay, students. Now simplify this. I hope you have understood till here. I am going to equate this result to the RHS to get our required value alpha. Now here 15 into 60C30 can be written as 60 factorial by 60 minus 30 factorial into 30 factorial. Now which is equal to RHS, what is given? Alpha into 60 factorial by 30 factorial whole square. Now simplify that. If you simplify this, you people are going to get here 60 factorial cancel. Now here 15 by 30 factorial into 30 factorial, 30 factorial whole square. Now which is equal to alpha by 30 factorial whole square. Now both of them cancel. Your required alpha value is 15. Okay students? Right. Next. Next students, now let us go to one more application. See this. One by 1 factorial into 50 factorial plus 1 by 3 factorial into 48 factorial plus 1 by 5 factorial into 46 factorial and so on. 1 by 49 factorial into 2 factorial plus 1 by 51 factorial into 1 factorial. This is the question which has to be simplified. See students, how I am going to simplify this. Okay, I would like to express this series as sum of its nth term or rth term. See, I am going to write R is running from 1 to, see, here 50 is there, here 1 is there, here 48, here 3, here 46, 1. What you are observing? 50 plus 1, 51. 48 plus 3, 51. 46 plus 5, 51. 49 plus 2, 51. 51 plus 1, 51. So, here 51 minus 51. See, this 1 you can write as 2r minus 1 factorial. 2r minus 1 factorial. And here 50 is there. Write this 50 as it is. Okay. Here 48 is there. Okay. Now 50. I can write as 51 minus 2r minus 1 factorial. Now it is suitable because if I write r1 here, 2 minus 1, 1 you are getting. If I write r1 here, it becomes 1. 51 minus 1, 50 factorial. If I write r2, 2 to the 4, 4 minus 1, 3. If I write r2, 2 to the 4, 4 minus 1, 3, 51 minus 3, 48 and so on. So in the next step, I am going to write here 51 factorial and 1 by 51 factorial outside. You may ask me, sir, why you have written 151 factorial in the numerator, 151 factorial in the denominator? Because in the next step it can be written as NCR. You know NCR is equal to n factorial by n minus r factorial into r factorial. So this looks like this formula. N 51, n minus r, this is r, this is n, r factorial, this is r. So what do you write that? 1 by 51 factorial into this total thing can be written as, so n value 51, C 2r minus 1. This is r. Okay students. Right. Now, okay, simplify. But R up to where? Here, R value. R is running from where to where, students? It is ended with 1. It is ended with 1 means, see here, 50, 50 or 51? 51 to 51s. Now, how many terms are there? So this is first, this is okay, second, this is third. So this will be 26 twos. Yes, 26 terms are there. There, how many terms are there? 26 terms, because here 2 26 52. 52 minus 1, 51 you are getting. Hence, so put R equal to 26. R is running from 1 to 26, no? So here this can be written as, students, this can be written, R runs from 1 to 26, no? So here put summation, R runs from 1 to 26. So this can be written as, here end value is n. Okay, 26, no? Yes, n value 51, sorry. 51, see, 2r minus 1, NCR. Yes. Now expand it. If you expand it, what do you get? What do you get, students? See, I hope you have understood this. This is NCR, n value 51, see r value 2r minus 1. But r is running from 1 to 26 only here. Okay? If n is 51, in its expansion we will get 52 terms. But all terms are not given here. 1 to 26 only given. Now get whose sum. See. Now 1 by 51 factorial. Now what about this? If you write R1, so this is going to be 51. So C1. If I write R2, 2 to the 4, 51 C3. If I write R2, I got this. If I write R3, 2 3 is 6, 5. 51 C 5 you will get, and so on. If I write to 26, so 51, 26 to the 52 minus 1, 51. So what you have got? Sum of coefficients of even terms. What are C1, C3, C5 and so on, Cn. These are the coefficients of even terms in the binomial expansion. C0, C2, C4, C6, C8 are the coefficients of odd terms. But these are coefficients of even terms, whose sum is 2 power n minus 1. As you have read while you are learning the concept, this sum would be 2 power n minus 1. Here n value is 51. Now substitute n value 51 here, so that you will get 1 by 51 factorial into 2 power 51 minus 1, 50. So this is your required sum for the given series, 2 power 50 by 51 factorial. Okay, students? Right. Now let us go to one more application. Right? Summation k runs from 1 to 10, k square 10ck whole square, which is equal to 22,000 into L. Then L is equal to how much? Okay, students? Here k square into 10ck whole square, which is equal to 22,000 into L. Then find L. So in this problem, students, you can write these two as 10 into 10ck whole square you can write. Now you know, students, NCR you can write as n by r into n minus 1 c r minus 1. You read this formula. If you write that formula inside, so you get k into 10 by k into 10 minus 1, 9c k minus 1 whole square. Now k cancel. Now what is left? 10 square 100. 100 into 9c k minus 1. So write that in place of this. Okay. But for this there is whole square. Okay. See here. K is running from where to where? 1 to 9 here. 9c k minus 1 you got. You cannot take 10 here. So you have to take up to 9. So here 100. So after simplifying this, you got k runs from 1 to, so here 10 only, 10 minus 1, 9 will come. 10. So 9c k minus 1 whole square. Okay. So now this is equal to 22,000 L. I hope you have understood, students. This you got after simplification of this. Now I am going to substitute this k value from 1 to 10. If I write 1 here, this is going to be 9c naught whole square. Next, if I write 2, 9c1 whole square. And so on. If I write 10, 10 minus 1, 9c 9 whole square. You know the formula for this, c naught square plus c1 square and so on, cn square, which is equal to 2n cn. In many problems we have used. Okay, na 2n cn, 2 into n. N value is how much here? 9. 9 or 10. What you have to take here? N value 10, no? Here k is running from 0 to, 1 to 10. 1 to 10, how many are there? 10 are there. Okay, students. So here 2n. So n value is 10. So that you will get n 10 or 9. Here n value 9, students, not 10. Because here 9c naught, 9c1 and so on, 9c 9, no? So here n value is 9. 9 means here how much do you get? 18. 18c 2n cn. N value 9. Okay, now write in place of the left side, write this value. So 100 into 18c9 can be written as 18 factorial by 18 minus 9, 9 factorial into 9 factorial. So which is equal to 22,000 L. Now 100, 2 zeros cancel. Now leftover one, can you simplify, students? So what is left? 18 factorial by 9 factorial into 9 factorial. Here 100 cancelled, 220 L. So bring it to the left side. Your L will become 18 factorial by 9 factorial into 9 factorial into 200. So this is your required result for L. So after simplifying, at last you will get to 221, students. Do this simplification. You know 18 factorial means continuous product of first 18 natural numbers in the numerator, and in the denominator also expand and simplify. At last you will get to 221. Try that simplification. Yes. Right. Next. See this problem. If summation k runs from 1 to 31, 31 ck into 31ck minus 1 minus summation k runs from 1 to 30, 30ck into 30ck minus 1, which is equal to alpha into 60 factorial by 30 factorial into 31 factorial. Then find the 16 alpha equal to how much? Then 16 alpha equal to how much? This is the question. Okay, students, shall we answer? If I write here K1, what do we get? 31 C1, here 31 C0. Okay, students. Now what is which formula you are going to apply for this? Your summation is there running from 1 to 31. So here you read this one C0 CR. So next C1 CR plus 1 and so on. Cn minus R Cn, which is equal to 2nCn plus R. 2nCn plus R. You read one formula. 2nC R only. So if you write R0, then you will get 2nCn. So if you apply this formula, students, so here what do you get? Here for this same, it can be applicable. So if I write K1 amma, so this is getting 0, this is 1. So here it is C0, here it is C1. C1. C0, C1. Next if I write 2. Yes. R1. 1 if you write here, what do you get? Students, tell me. Okay, here R. How much R? So for this you can apply 2nCn formula, students. Here n value is 31. For this n value is 30. N value is here for this 31. For that 30. 1 to 31. So put n equal to here 2nCn. Apply this formula for the left side. So for this one and this one, but here for this you have to take n value is 31, for this n value is 30. Okay, this formula only. So here, okay, if you apply this 2nCn formula for this, n value is 31, 2 31 is 62. See n value 31 minus, so there 60C 30. So difference of these two is equal to this much given. So simplify this. So what do you write? 62 factorial by 62 minus 31. How much? 31 factorial into 31 factorial. Here 60 factorial by 30 factorial, 30 factorial. So from the numerator, what do you take outside? From both. So here numerator 62 into 61 into 60 factorial by here 31 factorial you can write as 31 into 30 factorial and 31 into 30 factorial for the first one. Second one write as it is. So 60 factorial by 30 factorial into 30 factorial. In the next step, students, I am going to take 60 factorial by 30 factorial, 30 factorial outside. Inside what is left? 62 into 61 by 31 into 31. Here it is going to be minus 1. Now RHS alpha into 60 factorial by 30 factorial into 31 factorial is given. Now simplify inside. 31 1s, 31 2s, students. So here 60 factorial cancel. So here 2 61s are. So 1 22. So when you take cross multiplication, minus 31 by 31, here this 30 factorial cancel. Okay, ma, here 31 factorial is given. So in the left side, what is left? Here 31, here 30 factorial. 31 factorial is left. RHS alpha by 31 factorial. Now 31 factorial cancel. Your required alpha will be 122 minus 31, which becomes 91. 91 is your required answer. Okay, right. Next. See the students. If 1 plus 2 plus 49C1, 49C2 and so on, 49C49 into 50C2, 50C4 and so on, 50C50, which is equal to 2 power n into m, where m is odd. Then m plus n is equal to how much? Then m plus n is equal to how much? This is a given question. And find m plus n equal to how much? They said that m is an odd number. How do you answer to this question? Tell me. See students, this 1 plus this 2 I would like to write 1 plus 1. That 1 I can write 49C0. 49C0, 49C1, 49C2 till 49C49 you can write 2 power 49. Because you know sum of all those binomial coefficients. Here 49, this 2 I split as 1 plus 1. 1 you can write 49C0. 49C0 to 49C49 can be written 2 power n. Now come here. Here 50, yes, 2, 4 till 50 means sum of odd term coefficients, but here 50 C1 is not given. So add 50 C0, which becomes 1, no? Add plus 1 and minus 1. So if I write plus 1 and minus 1, here I will get here sum of odd term coefficients 2 power n minus 1. N minus 1 means 2 power 49. Here n is 50. 50 minus 1, 49. Minus 1 you will get. So which is equal to 2 power n into m. Now take the product of these two. A plus b, a minus b, which is equal to, this is a plus b, this is a minus b. A square minus b square. 2 power 49 whole square minus 1. So this plus 1 minus 1 cancel. This is left. 2 power 98. So which is equal to 2 power n into m. So in the problem they mentioned m is an odd number. M is an odd number means m value is 1, n value is 98. So we want m plus n. M plus n is equal to 99 is the required answer. Okay students. I hope you have understood how I have evaluated that. Next. See this question students. See, if summation r runs from 0 to 25, 50 CR, 50 minus r, C 25 minus r, which is equal to K into 50 C 25. Then K is equal to how much? This is the question. Now tell me, how do we do this? First I would like to simplify this. If I simplify, what I will get? 50 factorial by 50 minus r factorial into r factorial, and this one 50 minus r factorial by, so here n factorial by n minus r, 50 minus r minus 25 plus r factorial into 25 minus r factorial. So these two will be get cancelled. Now what is left? 50 factorial by r factorial, and here 1 by, so both of them cancel, 25 e factorial into 25 minus r factorial. Now this, students, I am going to split this as, see here, n value 50 factorial by r factorial into 25 minus r. 25 factorial is given. So I think, I hope you have understood till here. Hereafter, see, now what you have got? N value I would like to take as 50, here 25. R factorial, R value 25 you can take. Now here R factorial. Now do we simplify? Tell me, students. See, 50 factorial by, see, (25) factorial by NCR, n value, there 50C 25 is given RHS. So, okay, students, compare this one with RHS. What do you get? K into RHS, 50C 25 is there, 50 factorial by 50 minus 25, 25 factorial into 25 factorial. Now, is there any use? Yes, 50 factorial cancel, 25 factorial cancel. Now we would have to find K value. Send this 25 factorial to the left side, so that what do you get? So here 25 factorial by, students, here 25 minus r factorial into r factorial you got. So this is nothing but what? N factorial n minus r factorial into r factorial, which is nothing but NCR only. So here r value 25 CR. R is running from 0 to 25. Okay, students, this I simplified. I have equated to RHS, because RHS they mentioned as K into 50C 25. So here 50C 25 means 50 factorial by 25 factorial into 25 factorial you can write. I cancelled these two, I cancelled these two. So here this I brought left side, I got this one. This can be written NCR 25 CR. Here R is running from 0 to 25. 0 to 25 means, so here 25, if I write 0, 25 C0. If I write 1, 25 C1 and so on, 25 C25 you will get, which is nothing but sum of all the binomial coefficients 2 power n formula, n value up to 25. So here, this is our required result. K equal to 2 power 25. I hope you have understood these applications to students. So this class here itself I am closing. Thank you students. Thank you one and all.